Okay, we're going to be talking about section 4.1, starting in chapter 4, and we're talking about percentages, ratios, things like that again. So percentages are just a ratio where the second quantity has been scaled to 100. So anytime we talk about percentages, you should always think about that in converting things. We'll talk about that in a minute. So an example here is if you invest $50,000 in a retirement annuity, what is your return and the ending balance at a given rate of 3% per year? So 3%, we're going to rewrite that as 3 over 100. So anytime you see a percent, that's the way you could write it. And we're going to set that equal to x over 50,000. And then when we cross multiply, we come up with x equals 1,500. So 1,500 is the amount of return that you get. So if there's a $1,500 return, then your new balance is going to be $51,500. So what this ends up being is what we have on the right is rate, and what we have on the left is what we call principal, or the amount of money that you borrow. So this is where this formula comes from, where when we cross multiplied, we end up with principal times rate, and x is your interest. So this is where we come up with a formula that's equal to interest equals principal times rate. So then we have this chart, and what we're doing is we're converting from percentages to fractions to decimals. So if I have 75%, anytime I have the percent sign after it, I can rewrite that over 100. And then if I were to actually do the calculation, I end up with 0.75. So there's a rule that you can always move your decimal 2 places to the right to convert it back to a percent, or you can move your decimal 2 places to the left to convert it to a decimal. So again, 4.5%, you've got the percent sign after it, so I can write that as 4.5 over 100. So that would equal 0.045 if I put that in the calculator. So again, take my decimal and move it 2 places to the left, and that's where I come up with that 0.045. So here I gave you 275 over 100. So like in the other examples, whatever is over 100 is your percent. So it's 275%. Then if I move my decimal place 2 places to the left, I'm going to end up with 2.75. So if I take it from here and I move it 2 places to the left, or if I take 275 and divide by 100, I would end up with 2.75. The next one I'm given 0.0023. Well, how do I go from this column to the fractions or the decimals? So all I'm doing is I'm going to multiply this by 100. So if I multiply that by 100, it moves it 2 places to the right, which is 0.23 over 100, which is 0.23%. I accidentally put 2 examples on here the same. So you have 0.5 over 100, which is the same thing as 0.5%. And again, doing the math, you get 0.005. This is the same example. This one I have 7 right here. So if I do what I told you up above, you're going to multiply by 100. So that gives you 700 over 100, which is 700%. And then 100% would be 100 over 100, which is 1. So our last example here, we have a car loan that was issued for a term of 5 years for $18,000 with a 6% annual percentage rate. The fixed monthly payment is $347.99. So how much interest do they pay for 1 month? So we're going to use that formula that we just talked about. Principal is the amount of money you borrowed. So $18,000 is your principal. R is the rate. So this is your rate. And time is 1 month. Okay? So we're going to put that into our formula. 18,000 times 6 over 100 times 1 month, which is 1 out of 12. And if I do my mathematics, I get $90. So the interest for 1 month is $90. Now then the question says, how much interest do you pay for the life of the loan? Well, we're going to use a little bit different information. $347.99 is how much my monthly payments are. I make those monthly payments every month, so that's 12 times, for 5 years, and I come up with $20,879.40. That's how much money I actually paid back for the car. But I only borrowed $18,000, which means if I subtract those two, I ended up paying $2,879.40 for interest. So it's a little bit different than if I took this 90 and I multiplied it by 12 and by 5. I get a different amount. But the reason that this is because this is just considering 1 month's interest. And the way that car loans work, it works a little bit differently than that. And so that's why the $2,879 is different. Have a good one.